Um, so what I'm going to do now is just briefly go over what we put in our proposal and what our community is. So let's go to the first slide. So our community and our outreach. So initially, when I saw the call that came out, we were told that they were only really looking to fund one proposal per community. And so what is our community? Well, our community is materials and molecular modeling, and it's composed primarily of groups based in physics, chemistry, material science, engineering, but also earth and life sciences. I don't think, I think it's important to say right at the beginning that the MO community has always been at the very forefront of exploiting novel technologies and architecture, from the early IBM mainframes to current HPC facilities, including that at Archer and those abroad. So it's really key that we also engage and continue that good work. We are quite lucky in our community that we already have two HEC consortia, UKCP and MCC, and I've stolen this image here that Angelos originally created. It's been slightly modified, but you can see that we are based across a number of locations across the UK, the red and the yellow markers. We support over 750 users currently in Archer, the national machine, and based over 103 research teams. And in fact, we're using over a third of Archer currently. These two consortia, of course, don't include everyone. There are those that you'll probably know. There's these TYC, the Thomas Young Centre. So in London, all the material modelers across the different colleges have come together to form this virtual centre, the Thomas Young Centre. When there was a call that came out to develop tier 2 HPC facilities, i.e. computers that are smaller than the national resource but bigger than what typically is funded by one institution, the TYC got together with a number of project partners and expanded slightly out to all those marked there on the map in green to form what is now known as the MMM Hub. And we were quite fortunate to be successful again in the renewal to fund a machine that's very unique in that the architect's been that's good for what we like to do, what our needs are in the materials molecular modeling community. But it also, if you look at the people that are using the machine, it's quite clear that there's a wider community than just those that are part of the MCC and UKCP. So this is really a wider materials modeling community that I'm sort of trying to highlight here, that we're trying to represent. And of course, we know from that we're not reaching out to everyone. So we have on board CCP 9 and CCP 5, a way of trying to make sure that we do capture everyone across the UK. So this is quite unique in that I think this is the first time really that this wider community, particularly MC and UKCP, are working together along with the MMM Hub and hopefully everyone else that we haven't quite captured. So I would like to go through quickly, very briefly, sort of layman summary. I think we can all agree that high performance computing or supercomputers offer exciting opportunities, particularly where we're interested in, which is atomistic electronic structure modeling. The advent of exascale systems is the next dramatic step. Of course, we should be very wary that there's a high cost of both purchasing such a system, and so as Simon's already alluded to, it's imperative that we make sure that we are ready with appropriate software. The MM community have already shown that they have internationally leading experts, so let's push this forward and continue to develop software that's used both in academia and in this industry. We highlight in our proposal that we do consume over a third of UK's Archer facilities. As Simon's already alluded to, it's around 120,000 cores, that's sort of maximum peak of 2.5, 10 to the 15 flops per second. And we anticipate a smooth transition towards using Archer 2, which is about 10 times the size in terms of flops per second. But we also recognize that going to exascale, where it's going to be greater than 10 to the 18 flops per second, that we may not have that smooth transition, not unless we prepare ourselves. And certainly if there's a shift in architectures towards hosting accelerators. And I think it's true to say that many, if not all, of our MMM software will require some major changes. So one of the calls the call set out was for us to form a design and development working group, and this includes research software engineers, experts within our domain, which we brought together, but also bringing in experts from mathematics and computer science and people who are outside our domain. The ddwg, as we'll call it now, aims to separate out the fundamental mathematics of the problem from the computer science of the implementation. And of course, we highlighted a number of application areas that have already been targeted by EPSRC. So moving on to our objectives. First objective is to maintain and enhance our UK international reputation. And one of the ways of doing that, of course, is also to work with our international collaborators. To unite the UK's MMM community around our aims, as it were, as part of this, create this design and development working group to ensure that we are exascale ready, to identify and prioritise required algorithmic developments to enable a diverse range, and this is quite important in some ways, to bring the community together. We can't just concentrate on one piece of software, one technique. We really want to look at all the diverse range of material software that we currently use and try and work out solutions that will benefit most and not just one particular area. And maybe one way of doing that is to look at library files, for example. Clearly, one of the things we need to do is benchmarking and profiling our materials codes, identifying where the technical issues are from one massive hero calculation or indeed a set of parallel jobs, each perhaps being the size of currently what Archer is. Developing prioritizing plans, so we want to develop blueprints, okay, so in phase one, which is where we are now, identifying and key problems that we need to solve, and then developing blueprints that we might better put forward for funding that would come out of phase two. Identify potential data flow, problems between nodes and the I/O, data integrity problems, etc. Data management. Complete a significant step forward, becoming exascale ready. So one of the things that we'll need to do in phase one is to demonstrate our ability to make important progress. Otherwise, we might not be able to go forward in phase two. Maximize the impact. This is typical things that one does. Obviously, training events, dissemination. And down here, what I'm putting into words by going to contrast is two key aspects, really. And that's to increase UK skills and experience in exascaling, but also building and establishing a collaboration with our international collaborators who are also targeting effective exascale computation. And work effectively with the, whoops, I can't see, which is, sorry, just to hide that. Work effectively with other funded ddwgs and of course the four exascale hardware centers, which Jeremy hopefully will be giving us a bit more information on later on today. So here are the named investigators on our proposal. As you can see down the left-hand side, there's quite a number of people from different consortial groups, and I'm really pleased to see that we've all come together. This will be the first time that we've all worked together on one project. But you can also see on the right-hand side, maybe I could just show a pointer, maybe laser point, here we go, that we're including people outside our domain from mathematics and computer research computing to help us make sure that we understand fully and make good progress on our project. But at this point, I really want to also just highlight and thank those that helped put this proposal together. There's in fact one name missing, but I should add that Alexi Sock, who's not named, also helped tremendously on putting our proposal together. But I'd like to thank those like Phil. I know that we spent probably about 3 o'clock in the morning working on our proposal, and then waking up at 8 to find that the others highlighted here have also been working hard before I've woken up. So I'd like to thank all those that's helped, that's named, but particularly those that I've now just highlighted. Of course, it's also important to involve the project partners. Down the left-hand side are people that could have been named for the proposal as well. But importantly, on the right-hand side, we've got many people that we're looking forward to work and collaborate, and we'll be hearing from them later on this afternoon. I'm hearing questions, but I can't see them. Sorry, I've got a full screen, so I'll come on to your questions in a second. So I guess the main thing that you might be interested in is the manpower. What manpower do we have in our timeline? Well, here on the right-hand side is the Gantt chart, as it were, that we submitted as part of the proposal. We started a month late, so really where it says April, it should say May. And here we are on the kickoff meeting. You can see the various institutions here and their timelines. So we're here at the moment. We have, in terms of RSDs and PDRA support, Andy will be able to start with taking someone from a pool of experts at EPCC for 15 months of 1 day a week. I have Helen Duncan that will be starting here towards the end, the last 6 months of the project, hopefully working on one of those blueprints to try and demonstrate that we can actually do some code exploration.
So somebody, there haven't been that many questions, but James just notices that it's quite hard. It's a bit hard to see the whole timeline, I guess. One, because your slide's a little bit cut off on the right hand and left hand side, but that's not the big problem. I think the text is quite small as well. So maybe just as you're doing it, giving a rough overview of what it's going, just aware that people can't see the whole timeline.
Okay. Hopefully, though, if we put this online, they'll be able to zoom in further. We put the presentations in a place in our Google Drive that people can have a look later.
Yeah, that should be fine.
Yeah, so sorry about that. Andy's pointing out, I can't, obviously my screen's massive, I can see the text, but apparently you can't quite see what this flowchart on the side here. We've got months across the top here, and we've got UCL, EPCC, York, Lincoln, and STFC, and it's just highlighting what their activities are up to. But in terms of the sort of the manpower, as it were, as I was just pointing out, we have somebody working at Edinburgh with Andy working 1 day a week for the entire length of the project. Helen will be beginning in the last 6 months of the project working on some of the blueprints that we're hoping to be developed by STFC. Okay, Sergey and Peter will be beginning in a few months' time, and they'll be working full time for 12 months. And here we're very grateful to both Lincoln and UKCP because we actually only had 6 months funded from the project, but they've matched that funding to double the manpower. The MCC have also, courtesy of their EPSEC funding, have put in a COSEC support from Ian Bush, who'll be working 1 day a week for the entire project. I should say 15 months there, not 18 months, sorry. Tom Keel is also going to be working 1 day a week, and also Elaine on half a day a week. And they're basically be looking at the sort of the massive sort of hero calculation, looking at doing looking at data flow and doing multiple instances, and also looking at I/O flow. And then of course we have got a bit of admin support from Karen to help us along the way. Now, I'm sure there's plenty of questions. I'm sorry that the font is far too small, but perhaps we managed to get away with submitting that on one piece of A4. So whether we've broken any rules at all, I'm not sure. Anyway, I'm going to end my part of the talk now to keep us on time. So for the rest of this particular session, we're going to have a number of talks given from my colleagues. Essentially, they're going to introduce the 3 application areas and also benchmarking. Then we're going to pass over to Jeremy, who's going to give us a bit more detail on the hardware pilots. And then we'll end this particular session before we go out to the break-off groups with a number of talks from our research project partners. So if I can let go of the slide and hand over to, is it Ian going to go first?